The next method under transportation problem is Vogel's approximation method or VAM method. So this is the last method for calculating initial basic feasible solution under transportation problems. This VAM method includes 4 steps for calculating initial basic feasible solution. Step number 1. Find the penalty cost, namely the difference between the smallest and the next smallest cost in each row and columns. So in the step number 1, we find out the penalty cost by taking the smallest and the next smallest cost by taking the difference between the smallest and next smallest cost in each row and column. And step number 2, among the penalties as found in step 1, choose the maximum penalty if this maximum penalty is more than 1, that is, if there is a tie, choose any one arbitrarily. So what we calculated penalties in step 1, we choose the maximum penalties, and if maximum penalties is more than 1, we select only one penalties among 2. Step number 3, in the selected row or column as by this step 2, find out the cell having the least cost, allocate to this cell as much as possible depending on the capacity and requirement. So in the selected row or column, as what we do in step 2, we find out the least cost cell and we allocate the cell as much as possible depending on the capacity and requirement. Means, so now ಸ್ಟೆಪ್ 2ನಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಪೆನಾಲ್ಟಿನ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡಿರ್ತೀವಿ. ಸೊ ಆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಪೆನಾಲ್ಟಿನಲ್ಲಿ ರೋ ಅಥವಾ ಕಾಲಮ್ನ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಬೋದು. ಸೊ ಆ ರೋ ಅಥವಾ ಕಾಲಮ್ನಲ್ಲಿ ಲೀಸ್ಟ್ ಕಾಸ್ಟ್ ಸೆಲ್ ಯಾವುದಿರುತ್ತೆ ಅದಕ್ಕೆ ಅಲೋಕೇಶನ್ಸ್ನ ಮಾಡ್ಕೊಬೇಕು, ಆ್ಯಂಡ್ ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ದ ಸಪ್ಲೈ ಆ್ಯಂಡ್ ಡಿಮ್ಯಾಂಡ್ ರಿಕ್ವೈರ್ಮೆಂಟ್ಸ್. And step number 4, delete the row or column that is fully exhausted. Again compute the column and row penalty for reduce the transportation problem. Then go to step 2, repeat the procedure until all the rim requirements are satisfied. So after allocation is made, then delete the entire row or columns. ಸೊ ಆಫ್ಟರ್ ಅಲೋಕೇಶನ್ ಆದಮೇಲೆ ಇನ್ ಕೇಸ್ ಅಲೋಕೇಶನ್ ಅಥವಾ ಸಪ್ಲೈ ಸ್ಯಾಟಿಸ್ಫೈ ಆದರೆ ರೋನ ಡಿಲೀಟ್ ಮಾಡಬೇಕು, ಡಿಮ್ಯಾಂಡ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆದರೆ ಕಾಲಮನ್ನು ಡಿಲೀಟ್ ಮಾಡಬೇಕು. ಆ್ಯಂಡ್ ಅಗೇನ್ ವಿ ಕಂಪ್ಯೂಟ್ ದಿ ಸೇಮ್ ಪೆನಾಲ್ಟೀಸ್ ಫಾರ್ ಈಚ್ ರೋ ಆ್ಯಂಡ್ ಕಾಲಮ್ ಅಂಟಿಲ್ ಆಲ್ ದ ರಿಮ್ ರಿಕ್ವೈರ್ಮೆಂಟ್ಸ್ ಆರ್ ಸ್ಯಾಟಿಸ್ಫೈಡ್ ಆರ್ ಆಲ್ ದ ಸಪ್ಲೈ ಆ್ಯಂಡ್ ಡಿಮ್ಯಾಂಡ್ ಕಂಡೀಷನ್ಸ್ ಆರ್ ಸ್ಯಾಟಿಸ್ಫೈಡ್. ವಿ ರಿಪೀಟ್ ದ ಸೇಮ್ ಪ್ರೊಸೀಜರ್. So this is the example for VAM method. So find out the initial basic feasible solution for the following TP by using the VAM methods. So in this problem there are 4 destinations, D1, D2, D3 and D4, and 3 origins, O1, O2 and O3. So the origin, first origin supplies 250, second origin supplies 300 and third origin supplies 400. The total supply value is 950, and the first destination demand is 200, second destination demand is 225, and third destination demand is 275, and the fourth destination demand is 250. So this is the solution for the above problems. So computation of initial basic feasible solution under VAM method. So before going to solve the problem, first we check this condition. Means the sigma AI must be equal to sigma BZ, means the supply must be equal to demand. So here the total supply is 950 and the total demand value is 950, means there exists a initial basic feasible solution to the given TP. So after checking this condition, we go for step by step procedure to solve or to get initial basic feasible solution. So first we calculate a penalty cost for each row. So each row and each column. P1 means penalty cost for each row. So first we select the least cost and next least cost in each row. So this is the least, 11 is the least cost, and the second smallest cost is 13. The difference between the 11 and 13 is 2. So the first row penalty cost is 2, and the second row we select the smallest cost in first smallest cost and next smallest cost. So smallest cost in second row, the smallest cost is 10 and the next smallest cost is 14. The difference between these two is 4. And in third row, the smallest cost is 10 and the next smallest cost is 13. The difference between these two is 3. So after that we calculating the column penalties for each column. First, the smallest cost in first column is 11 and the next smallest is 16. The difference between these two is 5. And second column, in second column the smallest cost is 13 and the next smallest cost is 18. The difference between these two is 5. And in third column the first smallest is 13 and the second smallest cost is 14. The difference between these two is 11. In fourth column the smallest cost is 10 and the next smallest cost is also 10. So the difference between these two is 0. So after calculating row penalties and column penalties and we select the maximum penalties. So in column penalties and row penalties calculate ಮಾಡಿದ್ಮೇಲೆ ಯಾವುದು ಪೆನಾಲ್ಟಿ ಹೈಯೆಸ್ಟ್ ಇರುತ್ತೆ ಅದನ್ನು ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊ ಮೀನ್ಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಪೆನಾಲ್ಟೀಸು. ಸೊ ಇನ್ ಕಾಲಮ್ ಪೆನಾಲ್ಟೀಸ್ನಲ್ಲಿ 2 ಹೈಯೆಸ್ಟ್ ಪೆನಾಲ್ಟೀಸ್ ಇದೆ. ಸೊ ಇದರಲ್ಲಿ ಒಂದನ್ನು ಸೆಲೆಕ್ಟ್ ಮಾಡಬೇಕು. ಸೊ ಫಸ್ಟ್ ಐ ಚೂಸ್ ದಿಸ್. ಸೊ ಯಾವುದಾದ್ರೂ ಒಂದನ್ನು ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಬೇಕು. ಸೊ ನಾನು ಫಸ್ಟ್ ಕಾಲಮ್ನ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊತೀನಿ, ದಟ್ ಈಸ್ 5. ಸೊ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡ್ಮೇಲೆ ಲೀಸ್ಟ್ ಕಾಸ್ಟ್ ಯಾವುದಿರುತ್ತೆ ಆ ಕಾಲಮ್ನಲ್ಲಿ ಅದಕ್ಕೆ ಅಲೋಕೇಶನ್ ಮಾಡ್ಕೊಬೇಕು. ಸೊ ಐ ಸ್ಟಾರ್ಟೆಡ್ ಅಲೋಕೇಶನ್ ಫ್ರಮ್ ದಿಸ್ ಸೆಲ್. ಸೊ 11 ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. ಸೊ ಈ 11ಗೆ there are two rim values for this cell, 200 and 250. So I allocated the minimum rim value. So minimum rim value means that is 200. 200 minus 200 0 and 250 minus 200 is 50. So this column is deleted because the demand is satisfied. And then we calculated the penalty cost 2 for each rows and columns. So next, penalty cost 2 for row 1, first row. So first we select the smallest cost and next smallest cost. So ಇದನ್ನು ತಗೊಳ್ಳೋಗಿಲ್ಲ because ಈ ಕಾಲಮ್ ಡಿಲೀಟ್ ಆಗಿದೆ and already allocation ಆಗಿದೆ. So smallest is 13, next smallest is 14. The difference between these two is 1. So here the smallest is 10 and the next smallest is 14. The difference between these two is 4. So in third row the smallest is 10 and the next smallest is 13. The difference between these two is 3. And in column penalties, so first column penalty is nil because the demand is satisfied. And next D2 smallest 13 and next smallest 18. The difference between these two is 5. Smallest 13 and the next smallest 14. The difference is 1. Smallest 10 and next smallest is 10. The difference is 0. So here we select the highest or maximum penalty among these penalties. So 143510. So 5 is the maximum penalty. That's why I select this penalty for allocations. So ಈ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡ್ಮೇಲೆ ನಾವು 13, 18, 24 ನಲ್ಲಿ ಲೀಸ್ಟ್ ಕಾಸ್ಟನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೊಬೇಕು. ಸೊ ದಿಸ್ ಸೆಲ್ ಹ್ಯಾಸ್ ಲೀಸ್ಟ್ ಕಾಸ್ಟ್, ದಟ್ ಈಸ್ 13. ಸೊ 13 ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡ್ಮೇಲೆ ಸೊ ದೇರ್ ಆರ್ 2 penalties for this cell, 50 and 225. So assign minimum rim value, so that is 50. 50 minus 50 0 and 225 minus 50, that is 175. And next calculate penalty cost 3. So first row is deleted because the supply is satisfied. So the penalty cost 3 for first row is nil and second row is 4. 10 and 4, the difference is 4. And third row, the penalty cost for third row is 3. 10 minus means 13 minus 10 is 3. And penalty cost 3 for column wise. So first column is nil because it's 0. And second penalty cost, so the smallest cost is 18 and next smallest cost is 24. The difference between these two is 6. And column 3 penalty is 3 1 and this is 0. So among these penalties we select highest penalty. So highest penalty, this is the highest penalty. So ಈ highest penalties ಯೂಸ್ ಮಾಡಿದ್ಮೇಲೆ least ಕಾಸ್ಟಿಗೆ ಅಲೋಕೇಶನ್ಸ್ನ ಮಾಡಬೇಕು. ಸೊ ದಿಸ್ ಇಸ್ ದ ಲೀಸ್ಟ್ ಕಾಸ್ಟ್. ಸೊ ಐ ಸೆಲೆಕ್ಟ್ 18 ಫಾರ್ ಅಲೋಕೇಶನ್, ದಿಸ್ ಸೆಲ್ ಫಾರ್ ಅಲೋಕೇಶನ್ಸ್. ಸೊ ಫಾರ್ ದಿಸ್ ಸೆಲ್ there are two rim values, demand 175, supply 300. So I assign 175 because this is the least cost. 175 minus 175 0, 300 minus 175, then I'll get 125. And next calculate penalty cost 4. So this row is deleted, so there is no penalty cost, that's why it's nil. And for this 10 and 14 the difference is 4, 10 and 13 difference is 3. So this column is nil, demand satisfied, and this column is also nil. So 1, difference is 1, and this is 0. So among these penalties 4 is the maximum penalty cost. So I select this row for allocations, and in this row first row value, second row first column values, the values also means that there is no demand, there is no demand for allocating, and the second column or second cell is also allocated, means there is no demand for allocating. And in third cell ನಲ್ಲಿ ಇದೆ, ಬಟ್ ಲೀಸ್ಟ್ ಕಾಸ್ಟನ್ನು ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಬೇಕು. ಸೊ 10 ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊತೀನಿ. ಸೊ ಹಿಯರ್ there are two rim values, 125 and 250. So I allocate the minimum value, that is 125. 125 minus 125 0, and 250 minus 125, then I'll get 125. And next P5, penalty cost 5. So first row nil because already supply ne illa alli, and second row is also nil because supply illa, and the third row the difference is 10 minus 3. So same, the difference is 3. And next first column is nil, second column is nil, and the third column penalty cost is 1, and the fourth column penalty cost is 0. So among this penalty 3 is the maximum penalty cost. So that's why I selected this row for allocations. So among these, so in this row 10 is the least cost, so I selected this cell for allocation 10. So among these for this cell there are two rim values, 125 and 400. So I allocate 125 because it is the minimum rim values. 125 minus 125 0, so 400 minus 125, that is 275. And next calculate penalty, and next calculate penalty cost 6, and here penalty cost 6 for each row and columns. So this row is penalty cost is nil, and this row penalty cost is also nil, and this row penalty cost 13 is the least, and the next least is 21. So the difference between these two is 8. And next column penalty, so the first column penalty nil, second column penalty nil. So in this column the penalty cost is 1 because the smallest is 13 and next to smallest is 14. The difference between these two is 1. And this column 4 penalty cost nil because the demand is satisfied. And among these penalties I choose the highest penalty cost, that is 8, and allocated the least cost. So the least cost is 13, so I select this cell for allocation and selected. So there are two rim values, so both of the rim values are same, means the supply and demand both are satisfied. So 225 minus 225 is 0, 225 minus 225 is 0. So all the rim values are satisfied, all the supply and demand condition must be satisfied. So this is the solution for the above problem. So the conclusion is, so there are 6 positive independent allocation which are equal to m plus n minus 1. So that is, so in these allocations, so we allocated 6 cells, we select 6 cells for in allocations, that is 1 2 3 4 5 and 6. So this must be equal to the, this allocation must be equal or must be non-negative allocations. ಸೊ ಇದನ್ನೇ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳಿದ್ರೆ ಎಮ್ ಇಂಡಿಕೇಟ್ ಅ ನಂಬರ್ ಆಫ್ ರೋಸ್. ಸೊ ನಂಬರ್ ಆಫ್ ರೋಸ್ ಆರ್ 3 rows 1 2 3 and number of columns is number of columns 4 columns 1 2 3 and 4. So number of rows plus number of column minus 1, then we get 6. ಸೊ ನಾವು ಇಲ್ಲಿ 6 allocations ನ ಮಾಡ್ಕೊಬೇಕು. ಸೊ these solution or this condition ensures that the solution is non-degenerate basic feasible solutions ಅಂತ ಹೇಳ್ತೀವಿ. ಅಂತ ಹೇಳಿದ್ರೆ there is no improved or there is no optimality solution for this problem. So hence the transportation cost is given by 11 into 200 plus 13 into 50 plus 18 into 175 plus 10 into 125 plus 10 into 125 plus 13 into 275. So 2200 plus 650 plus 3150 plus 1250 plus 1250 plus 3575. So therefore the total transportation cost is rupees 12,075. So this is the solution for the problem.